Welcome to this paper about lifelong learning of end-to-end ASR. The major contributions of this paper are listed as follows. First, this is the earliest analysis for lifelong learning of end-to-end ASR. We adopted and analyzed previous lifelong learning methods for this task. We proposed data selection to improve data-based approaches. Firstly, the world is ever-changing, and so is our spoken language, so ASR should learn continually. In other words, the lifelong learning issue of ASR. After fine-tuning, the model might not recognize data from the past domains. This is the phenomenon of catastrophic forgetting. The baseline and upper bound methods of our task are fine-tuning and multitask learning. But fine-tuning suffers from catastrophic forgetting, while multitask learning usually cannot save all data from the past. So we adopt regularization and data-based approaches here to mitigate these issues. First, regularization-based methods try to use the previous model to regularize the current model. We consider elastic weight consolidation, synaptic intelligence, and knowledge distillation. Data-based methods try to save some data from the past to constrain the current model. We consider gradient episodic memory here. We also propose two data selection methods by choosing samples with audio lengths close to the median of each dataset and lower perplexities in their domains. In our experiments, the end-to-end ASR models were trained with Wall Street Journal, Libre Speech, and Switchboard sequentially. We first compared the multitask upper bound and the fine-tuning baseline by inspecting the word error rates tested respectively on the three datasets. The significant increases of word error rates in the first two datasets was the catastrophic forgetting. Now let's take a look at the averaged word error rate over the three datasets. With regularization applied, SI and KD surpassed the fine-tuning baseline. Next, we found our data selection performed better. We now inspect the learning curves. Fine-tuning and knowledge distillation oscillate severely during training, but GEM is more stable. So data-based methods stabilize training. Finally, we tried different amounts of saved data. The dotted lines randomly selected data, while the solid lines are our selection method. Therefore, saving a small amount of data is helpful, and our data selection is better. In conclusion, we adopted and analyzed various lifelong learning methods for end-to-end ASR. We found data-based are better than regularization-based approaches for ASR, and the choice of saved data is important. Finally, the task of lifelong learning of end-to-end ASR is a long-term goal.